Okay, so today what we're going to do is this video is going to be for those people who have trouble with factoring and would like to, practice some more. Now, for me personally, I find factoring quite simple. I can do probably all of these just in my head. I don't have to get a piece of paper out. However, I know most people aren't like that. So this video, I'm going to be showing you my thought process, how I factor these questions, and so that you can learn from me and maybe speed up your factoring because that takes up the most time for most people on tests. Now, please note that you should still try these questions on your own first because you may never know. You might be better at factoring than I am, and my technique might be total garbage. Anyways, let's start with the first one. First one is you should recognize this is called the it's called completing the square. So what this is we know that we have something in the form a squared plus 2ab plus b squared. We always write it as a plus b all squared. Now all we have to do is just find the quantities a and b, and we just plug it in and we're done the question. Now we relate these. We find out that x squared is equal to a squared. These are equal, so we can say a equals x, right? Then we can do the exact same thing for number 2. We don't use the last one. We don't use the last term here. Reason being is that b squared can b squared, right? And if b is -5, that still gives us 25, but this thing breaks down, right? So we can start. We just plug this in. 2x, we plug in x for a, b equals -10x, and we find that b equals -5. Very good. And finally, all we have to do is plug in our values. X minus 5 squared is our answer. Now you should also make sure that you can properly, that if you want to check your answer, that you could properly FOIL or expand this out. So what I do here, for factoring this, well, what I did was just recognize these patterns, right? These patterns is completing the square. That's the pattern here. Very common pattern that you'll see on tests. Now you just gotta be, flexible with what you're given and be creative. Now here, what we have this pretty ugly expression, but we can deal with it. So we notice that the first is in the form of a cubed plus b cubed. And we know this is called the sum of cubes. Now for the sum of cubes, we have an acronym for it so that it's easier for us to distribute the signs and stuff. It's called SOAP. And it's actually split up into 3 categories. So we have one here, and last one right here. So the S stands for the same sign. So it's the same sign as this, as a positive. And the O, it stands for the opposite sign of this. So if it's plus, then O means negative. Finally, AP means always positive. So regardless if it's sum or difference of squares, it's always positive. And we can break this down into A, since it's a positive, A plus B. We have A squared minus AB plus B squared. Keep in mind that this thing is not factorable, so so this is the final form you can get into. So let's just plug in our A and B. Our A is clearly x, A equals x, and our B is equal to 2, since the cube root of A is 2. Now we can just plug all these numbers in. X plus 2, x squared minus ax times 2, so 2x, plus b squared, so 2 squared plus 4. That's for the first side. So the green part, this is what we have here. Next, we're going to tackle on the blue side, which is x squared minus 4. Now, once again, this is just another common pattern that teachers would use. This is difference of squares. Keep in mind, this is only difference, unlike cubes where you have sum and difference of. And we should know this from heart. X squared minus 4 equals x plus 2, x minus 2, like that. So very simple. All we have to do now is combine these two. We combine these two together, and then so we have x squared plus 2, x plus 2, x squared minus 2x plus 4 plus x plus 2, x minus 2. Here we note the two common factors, right? So we combine them together. We factor this part out. And then we have x squared minus 2x plus 4. And since we're adding this part on, so plus x minus 2. Let's simplify this a little bit. So we get x plus 2, x squared. So we have negative 2x plus x, so minus x. Then we have 4 minus 2, which is plus 2. And we are done. This is our final answer right here. Completely factored. So just like the first example, these are just recognizing these patterns, these common patterns, which are perfect squares, sum and difference of cubes, and difference of squares. That's pretty good. Let's move on to the next example. Oops. Okay. So this one is it's just regular factoring. There's no special tricks. But keep in mind that when you're unless you have a really mean teacher, your factoring is probably going to be very simple, and it's going to be consisting of integers. What does that mean? It means you're not going to get fraction parts in your factoring. So how does this gives us a hint or an upper hand? Well, what we can do is, realize first of all, 3 is prime, so the only way we can split up 3 is 3 and 1. So we already have this part done for us. Now all we have to do is find two numbers that fit in here that will give us negative 2x and negative 8. Now let's start with negative 8, since it does not require our x coefficients. So negative 8, that means that one number is positive, one number is negative. So let's say num1, n1 equals positive, and n2 equals negative. Right? Now, since we're still dealing with integers, we just have to factor 8. So 8, there's two ways of writing it. We can write it as 1 times 8 or 2 times 4. So and n1, n2, we can change up, we could just put the correct number on the correct factor on each side so that this works out. So as I'm looking at this, we just have to think, well, what number times 3x such that when we minus that from x, it's going to give us negative 2x. So you can just think about this for a minute, but how I do it is I just go in directly. So we just have negative 2 right here, and we have positive 4, like that. Because all you have to do is just recognize that 4 times x, that's 4x. Negative 2 times 3x, that's negative 6x. 4x minus 6x, that is equal to 2x. That's how we do it. So what you really want to do with these questions is realize that you're probably going to get integers as factors, right? Because no teacher wants to mark decimals in your answers, right? That's just painful. So you can use that to your advantage by realizing that some things they have to be either or. For example, 3 is prime. It has It has to be 3 and 1, right? Very simple. Okay, so problem number 4, we have negative 6x squared plus 15x plus 36. Now, the first thing you probably want to do is factor out a bunch of stuff so that you get smaller numbers, since smaller numbers are easier for us to computate. So common factor for this is negative 3. Now, the reason I'm taking negative 3 out is because I like working with a positive number, positive leading coefficient. So negative 3 out of 15, that's minus 5x. And 36 divided by negative 3, that's negative 12. All right. So then we just have this part right here. This part is just much easier quadratic for us to deal with. Now we can leverage the same idea that these must be integers, right? So we can, and since 2 is prime as well, we can do 2x. We can split up in 2x and just regular x. Right? Now we have negative 12. Negative 12, we can split it up into, well, first of all, one's going to be negative and the other one's going to be positive. But we can split it up into 12 and 1, 6 and 2, 4 and 3. Those are all we're given. And from here, there's no really simple way of doing it. You just have to think about it for a while. Just think about it for a minute. But you clearly eliminate a lot of your initial guesses by just reducing it to integers. So here we can just look at this and we can see that negative 4 and positive 3 work. Why? 2x times 4, negative 4, that gives us negative 8x. 3 times x, what does that give us? That gives us 3x. Negative 8x plus 3x, that gives us negative 5x. So once again, we leverage the same idea of using integers solutions to simplify our initial guesses so that we reduce our workload. Now for me, I can just look at these equations and just boom, give it to you. But for you, you might take a while. So what you could do in the meanwhile is just go through every single possibility, since there's probably not that many for numbers that you can factor into, especially if they're prime. There's only 2 possible configurations. But for 12, you only have 3, right? 3 and 4, 1 and 12, and 2 and 6. You just go through all of these, and eventually you'll find whatever you need. And odds are it's probably not likely that you're going to get the correct factor the last thing you try. So just keep going. And just to make this correct, we have to write negative 3 at the front. 2x plus 3 equals x minus 4. Right? Always remember to keep what you factored out initially. Alright, so this one is a little bit interesting. X cubed plus x squared plus 4. Now, I don't actually know how to factor this, but that's okay because we've already done this question. Why? Well, this brings up the idea of being flexible. Well, you may see just x cubed plus x squared plus 4, but what I might see instead is x cubed plus x squared, and then we have positive 8 minus 4. I'm gonna write this in green, right? And these in brackets, right? Now, why is this useful? Well, we've already done this question, right? It's right here, right? X cubed plus 8, x cubed plus 8, and x squared minus 4, right? So clearly, we can just rearrange these numbers around so that we can get what we have before. Now, odds are on the test, you probably won't be blessed by your teacher by literally getting this exact same question beforehand. But what this brings up is creative thinking, wishful thinking, right? You only have a plus 4, but that's not useful for us, right? When we have x cubed, we like to have another cube in there. When we have x squared, we want to have a negative square number there, right? So what this is leveraging is wishful thinking. Can we get what we want by rearranging or rewriting our stuff? So from this thing, we can just restate our answer from number 2 and we're done. It's just simple as that. Because otherwise, you're going to have a hard time figuring out what answers you can get for number 5 instead of using, that shortcut. Now lastly, we have this really, ugly equation, 20x squared minus 17x minus 63. Now this is our last example. Obviously, it's going to be the most difficult one, but let's see what we can do. Now, I want to start working with the start because it's actually 20x squared, right? It's 20x squared. 20 is not a prime number. So we can't use the same idea of, example number 3, just to say 3 and 1, right? We also can't factor anything since 17 is prime and we don't have another factor of 17 anywhere else. So what I want to start with is actually with the end, the back of the expression. Because that one, it has less factors. 63, well, we can probably just split it up into 97, and if we need to, we could just move the 3 to the other side, so we have 3 and 21. Those are only two. Or finally, we have 63 times 1. But odds are, but it's probably easier we just work with the back. So I'm just going to put x here as our placeholder. And notice that it's negative, so we have a negative number in there. Now we have negative 17x in the middle. So I'm going to write down 63 for us. We have 3 times 21, 9 times 7, and 63 times 1. For 20, we're going to do the exact same thing. 10 times 2, 4 times 5, and 20 times 1. Now we can just look at this for a moment and just think about what might be our solution. And as you can see, we have 21, we have 63. Those numbers are pretty big, right? So our initial guess probably shouldn't be with 21 and 63, since if we multiply 63 by even something as small as 2, we're going to overload the other side, and we're never going to get to negative 17, right? Same thing with 21. Even if we have 21 times 2, right, that's still going to go over, and 3 times 10, that's not going to give us negative 17. So our first guess should actually just be 9 times 7. So we can just put 9, and we can put a 7 here. And we'll add in the plus and minus sign later. So this is our first guess, right? Always try to be logical with your guess. Don't just guess one of these numbers and just go with it. Be reasonable. What can be a solution and what can't be a solution, right? Now from here we can still try the same thing, just randomly guess all 3 combinations, since it's only 3 combinations, or we could be methodical about it and think for a moment, see what we can work with. Now let's see. What's 5 times 9? 5 times 9 is 45, right? And what's 4 times 7? 4 times 7 is 28. And, well, it just so happens that 45 minus 28, that's equal to 17, right? 7 plus 8, that's 15. 2 plus 1 plus another 1 that we carried over, that's 15. That's 45. So what we can do is, so it's 9 times 5 here, and we have a 4 up there. We have positive 9, and we have negative 7. And that's our solution right here. Now, obviously, for someone that has done many of these questions before, it's going to be pretty simple. Well, it's going to be easier for me to recognize these things, right? Recognize integers, recognize special factors, recognize, wishful thinking. But the key takeaway here is you want to make your load easier, since factoring is not really something it's not something people want to do, right? Because they always complain that it's just bashing numbers until you get it right. Well, you can simplify your work by just taking these simple steps and making some assumptions along the way, right? Like, so one great example here is this last question. I could have went through every single combination of factors of 63 and factor of 20, right? And that probably would have taken me 5-10 minutes, right? Probably longer than this video is going to be. However, I didn't do that because that's stupid. Don't work stupid, work smart, right? Just make educated guess that, you know, this is probably not going to be your solution. Neither will this one. Since big numbers times small numbers, they're probably still going to be big, right? So you just probably want to pick the middle of the pack, right? And the same thing goes for when we did 20, right? We could have done, you know, 9 and 10. We could have done x 10 times 2 with 9 times 7, or 20 times 1 with 9 times 7, but that's really dumb solution, right? That's not going to happen. So we just picked the most reasonable, we went with it, and just what happens, that worked out. And the key, and one more takeaway is, if you want to factor these things quickly, you're just going to have to practice lots of these questions. There's no other way. However, when you're practicing, make sure you're employing these techniques. Otherwise, you didn't learn anything from this video. So I hope that this really helped you. This is how I personally factor numbers in my head. I've done this so many times. I can probably do this without paper, but that doesn't matter since you're going to get paper on your test. But anyways, I hope this video helped you and your factoring skills will be a lot better. I'll see you in the next video.